All right, let's have at it again. Second part. Part two, problems 21 to 40. Write 2x squared plus x minus 28 as a product. So let's get this cleaned up a little bit. Oh, I don't want red. Red doesn't, yeah, red shows up all right. Let's get rid of it. 2x squared plus x minus 20. 2x squared plus x minus 20. Yep. All right. There's only one way to get 2x squared, and that's 2x times x. So we start there. Then we look at all the factors of 20. 1, 2, 4, 5, 10, 20. And whatever those numbers are, they get doubled. And so I'm looking at 2 and 4 by the look of it. 2. So what goes over here is 20, 10, 5, 4. Probably 4, 5, 4. No, I don't like that. Nothing coming to mind quickly here. I wonder if I got something that's wrong. So 1 minus 4a and c minus 20. 8, yeah, 81. So it works. All right. So there's a combination here that works. I'm having trouble spotting it at the moment. I copy it right. You old guys having a problem with this one. Tired brain. 28. So it's eyesight problems. That's what's the matter. I didn't give you the right problem. All right, but still, I think 160. Yeah, real tired brain here. So 28. All right, that helps. So 2x times x, start the same way. 28, 1, 2, 4, 7, 14, 28. Those get doubled. And then I want, after they're doubled, to be one away from the counterparts, 28. What we got? 14. We got 7. We got 4. We got 2. We got 1. All right. So 7 2s and 14. It's probably this one. So, yep. 4 times 2 is 8. 8 and 7 are 1 apart. I want positive, so I want that one positive, that one negative. Okay, so it's computer-like work. Hopefully you just, randomly look at the ones that have the most impact on the middle term, and you land on it usually. So that one's done. That's 21. 22. Conjugate 5 plus I, 6 plus I. 5 plus I. 6 plus I. So the conjugate of 6 plus I is 6 minus I. So I'm going to multiply numerator and denominator by the same number, so it doesn't change the size of the fraction, but it sure is going to change the look. So over here we got 30 minus 5i plus 6i minus I squared. Okay, I squared is -1 minus I squared. Yes, well, I'll do it later. So here we got 36 minus I squared, the middle terms cancel. Well, that's going to add 1, 37. So no reduced fraction. I think 37 is prime. I doubt we're going to get that up here. So 31, because that becomes +1. Minus 5 plus 6i is plus I. That's your answer. Be interesting. Ask you tomorrow if you saw that on an SAT question. And be interesting for me to find out what the SAT was like, whether or not some of the things we're working on were on there. All right, next problem. X squared minus 4x equals 4x. Now you're going to have to do these graphically as well. 4x is a linear function going up pretty quickly through the origin. So that's y equals 4x. X squared minus 4x could have been written as x times x minus 4. So we have roots at 0, an intersecting point there, +4. Eventually, this is going up faster than that. So there's going to be an x over here too. How are we going to find it? Well, x squared minus 8x equals 0. I'm just going to subtract 4x to that side. I see this. I recognize a rectangle when I see one. And that's telling me the area is 0, so you gotta get rid of one of the dimensions. 0 gets rid of this dimension, 8 gets rid of that, so you put it in factored form. Hopefully you can see your answers, you've isolated some variables. Positive 8, right? Come on, very tired brain at the moment. So 0 and 8 work. And that's the picture that goes with it. We're gonna start drawing those pictures on our tests. I'm putting the brakes on. All right, you got a lot in front of you, and you got a lot of time to chip away at it. And if you get all of that that's in front of you, you're gonna be in good shape. You're certainly gonna be in better shape than you were when you started the term. That's our goal. So let me put this in my hand. There we go. That's better. Now I can actually see what I'm looking at. So this is x cubed. Well, I know what to multiply x by to get x cubed, x squared. Okay, and then we've got minus 2x squared. Well, I know what minus 2 times x squared is. It's minus 2x squared. So it looks like I already got the first two. But now I've got to get, I keep looking at this, 3x. I got to multiply something times x that gets me 3x. I think I'll do 3. Okay, so far so good. Now I got minus 2 times 3 is minus 6. I don't want minus 6, I just want 1. Well, to get from minus 6 to 1, I think I got to go up 7. And I got to divide by x minus 2. And if I multiply this, hopefully you can see the addition of 7 there at the end. The x minus 2's cancel. To check it, we'll put a 2 in over here, because I know if I put a 2 in here, if I put the 7 outside the parentheses, a 2 is going to get me a 7. So I want to find out if a 2 gets me a 7 here, because I want one of those on my next test. So 2, that's 8. That's minus 8. Oh, those 2 cancel. 2 times 3 is 6. 6 plus 1. Oh, bingo, 7. Ah, this is right. Hey, you can tell I've been doing too much math today. It's all right. Let's get rid of that. Even the shoulder's sore. Oh. All right, next question. Perpendicular to 3y equals 2x plus 6. Well, I think I'll put it in slope-intercept form. I think I'll go 2/3 x plus 2. Yeah. And I want perpendicular. Perpendicular to something that's going up 2 and over 3. Well, it's got to go down. I know it's got to go down. Turns out it's a reciprocal. Negative reciprocal gets you perpendiculars. And it goes through AB. So x minus a plus b. Well, I should really get this document. I'll share this document with you over the internet, so you have it. Oh, somebody's calling me. Pause the video, pause the recording. All right, so I paused it, hoping that I haven't done this before, pausing it and seeing if it's recording again. I hope it is. Where are we? We did the perpendicular. All right, let me get rid of the perpendicular. Let's see what else we have here. All righty, we have no glasses on. Can I do this without glasses? Not really. We got to go with the glasses here. Okay, a binomial square. Done a lot of binomial squares. I'll just write the answer. So we've got 2x to the 5th minus 5y cubed z. And all of that's being squared. So we have 2 terms. Those are what nomials are. Bi means 2. So we've got 2 squared is 4x to the 5th squared is x to the 10th. We got a product of minus 10 of these things, x5, y3, z. But what do we do with that? We got to have 2 of them. So it's really minus 20. Okay, so that's what you get in the middle. At the end, you always get a positive when you square a negative or a positive. Looks like 25 y to the 6th z squared. All right, so that's how you do that. All right, I've got an absolute value greater than 30 here. So in order to answer this, we've got to find out when it equals 30. 3x minus 7 plus 6 greater than 30. I'm going to start with 3x minus 7 plus 6 equal to 30. That's all I do is I find out when that's true and then I use the symmetry, but we'll do both. Minus 3x minus 7 plus 6 equals 30. So what do we have here? We got subtract 6, so 24. Divide by 3, so 8. Add 7, 15. So 15 is a very critical number. Down here, we're going to probably get negative 8. So we got 24 divided by negative 3 is negative 8. Negative 8 plus 7 is negative 1. So that's where this V-shaped graph intersects a height of 30 at x equals negative 1 and at x equals 15. And if you add negative 1 and 15 and divide by 2, it gets you 7. That's a quick check to show you that those are symmetric. All right, now we just have to ask ourselves, do numbers bigger than 15 work? Well, I'll drop a million in here, and I think we can say pretty quickly true. These are linear functions, so you get sign changes. And so that's what's going to work. And we can see that once I get past 15, right, keep going up, those x's are getting bigger, 16, 17, right? I'm much bigger than 30. And once I'm less than negative 1, I'm definitely bigger than 30. And so therefore this is true. And then we express our answer using interval notation. So what's the interval notation? Was it greater than or equal to 30? Just greater than. So those numbers don't work. Those numbers don't work because they're not making the V shape bigger than 30. So we've got negative infinity to negative 1. Also 15 to infinity. And there's your answer for that. Yeah, camera's okay. Let me get it a little better. In case we have more. Yeah, I guess I might have not gotten the answer to that one, but hopefully you did. What's next? Hot coffees, what's next? Tangent x plus 1 equals 0. Tangent x plus 1 equals 0. You're probably still at the stage where you got to know what that stands for. Okay, with this language, that stands for an angle. So we're trying to find an angle where the tangent function, which is opposite over adjacent, will give us negative 1. And that's a ratio. Unfortunately, it doesn't look like a ratio. But if you realize that every integer is divided by 1, it looks like a ratio now. So the question is, where do we get negative 1 to 1 ratios? Well, I think we get them over here and over here, because if we look at those, we can see 45-degree reference angles, and the heights are negative and the width's positive over here. Over here, the height's positive and the width's negative, and they are the same side lengths, magnitude. So I'm seeing 4 parts. I'm seeing 8 altogether. I think pi over 4 gets me a height to width ratio of positive 1. Pi over 2 straight up, we call 90 degrees. That's not even a triangle. Looks like my first one's over here at 3 pi over 4. No 4, no 5, 6, 7 pi over 4. So 3 chunks of 45 is 135-degree angle, if we're in angle degree measurement. And 7 times 45 is 315. Those angles, when we look at the opposite to hypotenuse ratio, give us negative 1. And negative 1 plus 1 is 0. And I'm only looking at the unit circle when I talk about 0 to 2 pi. We could keep going around the circle forever, keep hitting these places. That's called a general solution. I'm not asking you for a general solution. All right, so a very similar question now. This is all the new material. 2 cosine x minus 1 equals 0. Well, cosine, I've been asking you to think of it as a width. All right, so we know we want widths that equal 1/2. Hope you're pausing the video and giving these some tries before, but even just following at this stage is useful. Because if you can't do them, then you gotta follow, right? So you can do it yourself. Again, what does that represent? With this language, we're looking for the angle. So here's your circle. Not too bad. All right, that's pretty bad. That's off center, but the old shoulder's getting tired. So as I go around, this is a distance of 1. I'm gonna draw triangles, right? But I'm gonna erase as I go around because my widths are getting shorter, 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 shorter. That's about halfway. Right there. Right there. That's about halfway. So I got to connect that, bring it down, and I can see that that's a 60-degree angle. And 60-degree angle right here. 60 degrees gives me that distance, and that distance is a half. And 2 times a half is 1, and 1 minus 1 is 0, and boy, I like that. Now let's see if I can get another 1/2. Okay, so we're here. No width up there. At 90 degrees, negative width over here. Oh, I lost my ruler. Oh, but here it goes again. We got to get to a half. Well, that's about here. Oh, I'll do that. I'll do that. Oh, well, that's 60-degree reference angle. But I'm 60 degrees less than 360. You know what? I think that's 300 degrees. That 300 is 5 chunks of 60. I think that's 5 chunks of 60, and pi over 3 is another way of writing 60 degrees. So 5 pi over 3, which is 5 times 3.14 divided by 3. That's a little bit bigger than 5 radius lengths. Let's say 5.1. So let's go back to that circle. I'm getting better with this. And let's go 5 radius lengths. Let's see where it takes us. That's way too far. So let's call that a radius right there. Because I think I'm way too far. Well, that's 1. That's 2. That's 3. That's 3.14. But 3, that's 4. That's 5. I did. I don't think actually that was too bad. So that's 1. Yeah, that's much further. 1, 2, 3. But that's anyway. You get the idea a little bit, I hope, by playing around with the radius length. And again, probably something I did a long time ago, but maybe I need to do it more often. This is what you're used to for a degree symbol. But if I kept going around, right, there's 360 degrees once around. That's also the circumference of a circle, right? And circumference is 2 pi r. And if we make r 1, then 6.28 radius lengths. Doesn't matter the size of the circle. It's just another way to write an angle. But it's far more useful when we start solving real problems out there, because that's just a flat out number, right? We don't want to put degrees in on the x side of a column. Numbers work better. Well, degrees are numbers, not generic numbers. Whereas we can think of the radian measurement as a generic number. Okay. Not sure I wanted to say that, but ln of 2, 3, approximation, and then rules of logs here. Well, ln of 2 is meaningless unless you put it on top of e. Right? It's meaningless. So what is 2? E to the 0.7. So what is our approximation? 2.1. So what did you do? You multiplied 3 times 0.7. And what is 0.7? 0.7 is the ln of 2. So therefore, I guess the ln of 2 cubed could have been written as 3 times ln of 2. And that's one of your log rules. These exponents can be put in front of that exponent because power to power is multiplication. Okay, this is an exact answer. All right, so e to the ln of 2 is 2. I don't know what else to say about it. So hopefully, when you go back and just do this without commentary, The original problem was the ln of 2 raised to the 3. Well, our log rule is 3 ln of 2. And that's equal to 3 times 2 points, 2 ln of 2.7, 3 times 0.7, approximately. So this should have been an approximation symbol. And that's approximately 2.1. So what is e to the 2.1 approximately? It's 8. Put it in the calculator. It's probably 7.989, something like that. 8's close enough to have a feel for it. So yeah, 2 to the 3 is 8, right? And 2 times 2 times 2 is 3 times, and that's e to the 0.7 times e to the 0.7. I don't need that. 0.7 e to the 0.7. We can see 2.1 there. All right, so how much more do I want to do here? There's a bunch that are, there are a bunch of problems there that I put little asterisks on because it's whatever kind of symbol that is. Well, let me get this one done first. ln of e to the 7 over e to the 4e. All right, well, that can be simplified to be the ln of e to the 7 over e to the 5. That's the ln of e to the 2. What's the exponent you put on top of e to get e to the 2? Well, it's a 2. Right? We don't write the letter e here, but e squared is, you know, how you make that number in the parentheses. I wanted to look at it from a standpoint of rules of logs. So what did we do? Well, we did some subtraction, right? Didn't we do 7 minus 4 minus 1? Isn't that how we got the number 2? So isn't 7 the exponent you put on top of e to the 7? Isn't 7 what you put on top of e to get e to the 7th? And aren't we subtracting the exponent to get that? And aren't we subtracting? You have to think about this some. And in the previous problem, we said that exponent can go in front of this one. That exponent can go in front of this log. That exponent, 1, can go in front of that. And I know what ln of e is. What do you put on top of e to get e? That's a 1. Which means this is 1 times 7, which is 7. This is 1 times 4, which is 4. This is 1 times -1, which is -1. And there's our 2 again. That's from the rules of log perspective. And you're going to work with that now till December 13th. Okay, and I don't think you should worry until the end of October. Because then you're going to get, you know, another 5, 6, 7 days of practice and see if it means something to you in 7 days. So e to the ln of 3x squared. Okay, so what is this saying? I'm looking for the exponent on top of e that gives me 3x squared. And once I find that exponent, I'm going to put it on top of e. I think I'm going to get 3x squared. Now, that's going to take you some time to sort out. To help you, I'll do log base 3 of 9. And I'm going to put that exponent on top of 3. Well, I know the exponent you put on top of 3 to get 9. It's a 2. So that means I'm doing 3 to the 2. Oh, and that's 9. Oh, boy, that's what's there. Maybe I can do, what do I put on top of a 4 to get a 4? I think that's a 1. Oh, well, let's put that 1 on top of 4. I think I'm getting 4. Let's put a 5. And let's put 5 squared. Well, I'm putting the exponent that I need to put on top of 5 to get 5 squared. I think that's a 2. Let's put a 2 on top of 5. I think I'm getting what's in the parentheses. Hope you're getting the idea that those are inverse operations. At least that's what I was hoping you'd see. All right, I think this will be the last one I do. Now, we've got one more at the bottom I want to make sure you do. All right, so I'll do throw out 39. 4 plus or minus 3i. You know the drill. So x minus 4 equals plus or minus 3i. At this stage, just square both sides, and you're gonna get x squared minus 8x plus 16 is equal to 9i squared. 9i squared is equal to -9. So we're gonna bring it over here and get x squared minus 8x plus 25 equals 0. You get that, you get one of those. Now I'll erase and we'll go back to the original. How do we get back to the original? Well, I can't factor, so I'm gonna do completing the square on x squared minus 8x, which is x minus 4 squared minus 16. That is equal to what's in the box. I still have 25, and I want that to be 0. I'll move that over, which becomes -9. X minus 4 squared equals -9. I'll do the plus minus the square root of -9 over on that side, which means that this is now gone, but I didn't move it until I move it up a notch. I know what this minus sign, I know I put that outside, and I know the square root of 9 is 3. And now -4 goes to the other side and becomes +4, and that's where we started this whole shebang. Last problem. Number, what I'm gonna do for you, 33. Okay, the other stuff I really is newer, came from an archive worksheet here. Happy to show you what that is, but I'm not gonna hold you accountable for them. X plus 2 over x minus 5 greater than or equal to 0. Do this the same way you're doing those other inequalities. Find the critical numbers, -2, and I know that's to the first power, so I know things are gonna change. This is to the first power, so 5, sign changes, put 1,000,000 in. 1,000,000 gets me a positive numerator, 1,000,000 gets me positive denominator. Is a positive divided by a positive greater than or equal to 0? True. Put a 5 in here. If I put a 5 in, I get 7 divided by 0. Is that greater than or equal to 0? Heck no. You can't divide by 0. You can't use the number 5. Sign change. That will work. 0 over -7, that's fine. That does equal 0. So that does work. Sign change. So what do we have? -infinity to -2, which does work. Union 5 to infinity, 5 doesn't work. All right, I'm hoping that I came in under 40 minutes. If not, I'm gonna be a very unhappy camper. End the meeting.